Find the critical value Z sub alpha over 2 needed to construct a confidence interval with the confidence level of 96%. Sketch the Z curve showing the relevant information. Include the calculator function and input values. First, sketch the Z curve. Label the axis. And put the level of confidence in the middle. And to find the critical value, here we use in norm for the area to the left of this line. So this area right here can be found by subtracting 0.96 from 1, okay, 0.04, and dividing 0.04 by 2, so you have 0.02 in each tail. And when you add these two, you get the area to the left of this line. So now using the calculator function in norm, and first you write down the area to the left of the z-score and the mean and standard deviation of the standard normal curve. So the TI, compute the value, and you get 2.0537. So this number right here is 2.0537. Find the critical value of T sub alpha. If alpha is 0.10 and equal to 45, and the alternative hypothesis states that the population mean mu is greater than a particular value mu naught. We start this problem by graphing the t-curve and locating the alpha in the right tail, since we have a right tail to test. And using the calculator function in t, and the arguments are the area to the left of this line, which is this area right here, and that should be 0.90, and we get that by subtracting 0.10 from 1. So 0.90 here, and then we put the degrees of freedom, which is n minus 1, and n is 45, so the degrees of freedom is 44, and we enter this into the graphing calculator. Then we get 1.3011. Find the p-value for a hypothesis test if its z-data is 2.06 and the alternative hypothesis is mu not equal to mu naught. Graph the z-curve. Graph the z-curve. Locate the test statistic. Now we have a not equal to sign, therefore we have two tails to test. So the p-value is in both tails. Okay, so in each tail there's a half of the p-value. Now the p-value is obtained via the TI function, normal, CDF, with the lower limit for this range here, so 2.06, and the upper limit, a very large number, and then the mean and the standard deviation. The value of this expression here is 0.019 0197, and the p-value is 2 times this value. Therefore, p-value is 0.0394. Find the p-value for a hypothesis to say the t data is negative 1.98 and the sample size n equal to 33, and the alternative hypothesis states that mu is less than mu naught. Draw the t-curve. Locate the test statistic. And because of the sign in the alternative hypothesis, know that we have a left tail test. So the p-value is in the left tail. And to find the p-value, we use TCDF, and then we enter the lower limit of this region here, and the upper limit, and the degrees of freedom, which is 32 in this case. Then we get the p-value of 0.0282.